Hello everybody, myself Yash Borkar. I have previously worked on a lot of data science as well as ML projects on OCR and grayscaling ones, and today we have got another opportunity to work on an ML project on iris classification. So let's head to my computer screen so I could explain you the project better. Now, iris classification isn't that difficult of a project, so even if you're a beginner in the field of machine learning, you will easily grab up with the concepts and the project would be a good start for you. Alright, now that we are on my computer screen, let me quickly launch my Jupyter notebook. You can like Jupyter notebook is what I'm preferring to write my code. You can also use other platforms like the Google Collaboratory. In fact, I have another collab open here. That's where I have previously done the same ML project. But if you want to publish this ML site on a public domain, then I would prefer a Jupyter notebook, because that way you can store your files in your local device and then push it to Git and then work on the Flask and other render things. So for now, let's close the collab and we'll focus on Jupyter notebook. Before we even create our notebook, I would suggest that create a new folder on your desktop or your preferred place, and then store your notebook and your checkpoints there, because we'll be needing other files to be downloaded and stored in a place in the same directory where we are saving our project. So if you're storing it on the default location where Jupyter notebooks are stored, it could be quite difficult. So I would recommend make a new project and then store your files there. So in my case, I have on my desktop, I have this demo folder. That's where all my files, you can see my iris dataset, my saved model, my deploy.py files are stored here. So that would be better. Now I'm opening my notebook, which I have named iris classification. Right. So the notebook is opened. Now let's go ahead and learn what the ML project is all about. So basically we are classifying a flower called iris. It has three species, namely Centosa, versicolor and virginica. You can read the description here of the project. Iris classification is a typical machine learning classification project where we use a data set to train the module to identify, recognize the target. There are three species of iris flower. When a new flower is given, we need to predict it belongs to which type. Following figure shows the samples of three flowers, right? So we're basically using a data set like I showed you previously. The iris.csv file is our data set. You can also go to Kaggle, I believe, and search for your iris data set. You can find a lot of them because it's quite a common project now. Even if you couldn't find, I'll obviously link it in the description so you can go ahead and download it from there. Now let's come back to our notebook. So you got the concept of what we are doing, right? And we will be using the data set, will be having labels with information such as sepal length, sepal width, petal length and petal width. So we'll be having all this data set with values, and from there, from those values, we can classify what kind of species we are targeting. So Centosa has these values, then we have versicolor with these kind of values, and virginica. So we'll be having 50 50 50, that means 150 labels, 50 for each species. We'll see that further. Now let's go ahead and start. I have pre-written my code so I could save time in explaining that instead of writing it all manually. So in the beginning, you will basically have to import your libraries. I am importing scikit-learn, NumPy, pandas, matplotlib, seaborn. All these matplotlib and seaborn are basically for your visualization. Pandas, NumPy you will require basic libraries. I would recommend, if you are unaware about them, then go ahead and read them, like what each library does. And then once you're done importing all them, I have also installed scikit-learn, whatever you want to pronounce it, because further I required it somewhere. So apart from that, once you are done importing all your libraries, you can go ahead and load your data set. So like I showed previously in my folder, so if I go ahead, one sec. If I go ahead and search for demo, which is my folder name, you can see my iris file is saved here, which is the data set. That's what I have called here. I have used df equals to pd.read_csv and then mention your file name here. and with df.head I am basically displaying the top 5 elements of the dataset. So you can see we have your serial number, then a column of id, and your sepal length, sepal width, petal length and petal width, along with the species name, right? So the top 5 elements are displayed. If you go down further, after 50 you will see for versicolor and virginica likewise. Now what I am doing is I am deleting the id column because that might be something that can interfere with my accuracy. So I am using df equals to df.drop, and then I am mentioning the column name here, and then again if you write df.head, you will see that the id column is now deleted. Now what we are doing is displaying some statistics and some data of our data set. So I'm using df.describe, which will give me the count of all the labels I have, the mean values, the standard deviation, your percentage and max, all these data. Again, if you use df.info, you will get the data type and your null count. So from 150 data set, we have no null count here, and the data type mentioned is float 64 for your labels, and for your species you have data type as object. Okay, now further what I have done is I am again like for clarity I am displaying what are the label counts for each species. So you can see for Sentosa we have 50 label counts, then for versicolor 50 and virginica 50. So we have a total data set of 150. Right, now we are doing is now what we are doing is pre-processing. Here we are basically first checking out if we have any null values. Again we are confirming it. So df.isNull dot sum will give us if we have any null count, so we could further remove those null values, so our accuracy improves. Now if you see here we have 0 0 0, so we don't have any null values, which is good for us. So let's move on to the next stage where we are doing data analysis. Now df.sepal. So in data analysis we will be basically visualizing our data. So if you read a data set, it will require a longer time to understand it, but if you are visualizing it, you can easily understand. For example, I am using a histogram here, .hist for sepal length. So if you see the entire data column of sepal length, you will have it visualized here in the form of histogram, and you can see how it is in the form of a curve. So that basically tells us that the data is kind of in a good coordination. We have good accuracy in the sepal length column. Same goes with sepal width. We are drawing a histogram which looks like a curve, but if you see the histogram for petal length, right, you can see that it's not exactly a curve. We have two separate histograms plotted here. So that basically shows us how the labels in the petal length are kind of tricky. We might need some correction here and there for good accuracy of our data. Same goes with petal width. You can see the histogram is quite different. Now since we are visualizing it, it's better to understand how the data set is going, right? Now further we are plotting a scatter plot here for more understanding. I'm first creating the list of colors. So basically red is what we are representing for virginica, orange for versicolor and blue for Sentosa, and then we are plotting it. Our scatter plot is sepal length versus sepal width. So you can see on the x-axis we have sepal width, and on the y-axis we have sepal length. So now you can see if you see the legend, right, you see blue is represented by Sentosa and it's nicely separated. You can see red and orange dots are mixed with each other. So virginica and versicolor have labels which are similar. The values are kind of similar to each other. That's why they are intersected. Now from this we can see how Sentosa has a really good graph here. So we can see the data for Sentosa is quite fairly simple to analyze. Now further we are plotting other scatter plots for we plotted for sepal width and sepal length. Now we are plotting it for petal width and petal length. You can see the graph is again different. This will help us visualize how we are going ahead with it. Now next we are again plotting it for petal length, sepal length, and then petal width, sepal width. So all this scatter plot will help us analyze the data better, and also the machine to understand the data better. Now further we are plotting a correlation matrix. We are using df.corr for correlation, and you can see the values here. the values are usually between 1 and then closer to -1. And then we can plot the heat map with the data. So we see sepal length, sepal width, they all have their heat maps here. So sepal length versus sepal length, sepal length versus sepal width, so we can plot it better. Now even the machine can understand the data with these kind of visualization. Now earlier I used a label encoder here. So so earlier, if you see the data, if you see the table that we printed, you can see the species column is actually giving out the name of the species, which is Sentosa, and further down if you go, you will see Versicolor and Virginica. So instead of that, what I wanted is it like Sentosa is given with a label, a number. So Sentosa is represented by 0, Versicolor by 1, and Virginica by 2. So that way it's easier to calculate. But then later I found that it's not really necessary. So label encoder, you can skip it. Now we're training the model now, training and testing the model. So I went ahead and imported a bit of modules here. So I have imported train, test, split, and logic regression, and neighbor classifier, decision tree. All these are, so train, test, split, and logical regression are basic modules. The decision tree classifier is a better module. So basically we are just training and testing the data. You can see in the code we are taking the species column, and we have given 30% for test size. So basically we are allotting 30% of the data for testing. So of course for the rest of the 70% will be there for training the data. From 100% of the data we are using 70 for training, 30 for testing. And you can see I have done my logical regression here with the module that I have imported here. With the module that I have imported here, I have tested the accuracy with logistic regression, and you can see I have got 88.8888 as my accuracy. Now we will be again doing logical regressions and printing it out, so we could improve our accuracy somehow. So like you have seen above, I have imported k neighbors classifier, and I'm using it here, using that module here, and then printing my accuracy. I'm basically trying to make the accuracy more closer to 100, so that the data is more accurate and the module could learn better. Module could give better outputs. So you can see after using k neighbor, I'm getting 93%. So we are jumping from 88 to 93% accuracy. Again, we are using the classifier here, and now I am again using the metrics. I've performed another test, so I got 93. I think that's the max I went, right? So after I have visually trained the module and done the pre-processing, I could now guess the accuracy, which is 93 at the most I have got. So yeah, we could end the ML model here. We have done all the training necessary for the module to identify what kind of species we want as an output. So right, so we could end our ML module working here. You just need to save this file. The code, don't worry about the code. I'll also give a text prompt in the description, so you can even see the code and then check it for yourself and then write the code. So right, your ML model is done here. Now save this file on the folder, on your new folder, and then we'll move ahead. Alright, hope you have understood the process so far, how we have trained and tested the module on the machine learning module on our Jupyter notebook. Now we have gone ahead and saved our notebook on the desired folder. Now let's get back on my Jupyter notebook, and I'll reopen my file. Now what we are going to do is that we will be using Flask to locally host this ML web app, and then we'll be watching our desired result on a locally hosted server. So once we are done with the module, right now we ended with our performance testing, where we have got 95% accuracy. Let me rerun the cells again. So go to cells, click on run all, and let's give it some time. Right, so all our cells are running again. We can see 93% is our accuracy so far. Now what we need to do, if you see this cell number 73 again, so we are basically saving our model now. We are using pickle, we have imported pickle and given our file name, which is saved underscore model.sav. You just make sure you use .sav file format. You can name whatever you want. Now what I'm doing is I've saved my module again. I think I got some problem here, so I've resaved it, the updated model, right? So I couldn't figure out if my model was saved. So what I've done is I've changed the code such that if my module isn't saved, it will print an exception saying that error saving the module. But now if you see, I've gotten results saying model saved successfully. So let's do some testing again. So you see, I have loaded the module here. Now let me go ahead and say xtest dot head. Right, so this was our data set. We have our sepal length, width, petal length and width. Let me if you can see here, I have already checked out if it's giving out the correct output that we want. So for example, let's say I'm a user. I will be using load underscore model.predict, and this time let's use some simple values. Let's say 4 is my sepal length, 3 is my sepal width, and 1 is my petal length, and 5 is my petal width. Now if you run it, see the output shows Vajanika. Okay, so so basically the model is working right. It's detecting all your values and then comparing it with the data set, and it's giving out the result Vajanika. Right, so now we can say that our model is working fine. We have also saved the model, and previously, like I told you, create a different folder on your preferred location. So in my demo folder, you can see I have my saved underscore model.sav, which is a sav file 2 KB. So the module is saved now on my location. Now further we'll be using VS Code to deploy this thing locally using Flask. So let me go ahead and open my Visual Studios, and you can see I've already opened my folder here. Demo folder is open. I have my pynb checkpoint here. Then I have my iris classification notebook, and just go ahead and open another file and name it deploy.py. That's where we will be having our Flask code. Also, I would request you to create another folder within your demo folder or whatever folder you have made, and in the templates folder create an index folder. So for example, I have my index.html file stored in the templates, and I have my deploy.py. The detects scikit-learn is not important. I was just checking my scikit-learn version if it's fine. Now this is our iris classification project, which is saved here, and we have our iris.csv dataset. So go ahead and open deploy.py. That's where we will be using our Flask code. So I have used from Flask import Flask. Obviously we are importing Flask and we are rendering the template. I have used the Flask with the default name, and I have loaded the module here. You can I will also link this code below, so you can copy paste it, or you can just understand it from here. So I'm basically loading the module, and like we previously saved our module with this name, saved underscore module.sav. And then read it. Now I'm using app.root to root my index file. So basically when we are loading it on our local server, it will be using this index.html file to host it. Now I'll show you further how we are doing about the index. Now I have used app.route, and again I will be, so we need to give Flask the procedures, like what all things have to be taken as input, right? So let me cross check this, like if the series is fine, sepal length, width, petal length and width, right? So sepal length, sepal width, petal length, right? So we'll just have to mention all this, that these are supposed to be the inputs, and then you have to throw the output, and then you will end it by if name equals to underscore main underscore. That will basically tell it that the code is finished here. Now your deploy.py code is done. Let's jump back to index. I have created a very basic index file here. I've used body, and then I've just created like a label sepal length, and then taken the input. So if I open it, on my browser, if I go to demo, and in the templates I have my index file, as you can see. So if I'm opening it, this is how the index is. It's a very basic index. You have your sepal length, sepal width, petal length, petal width, and then your class result. So that is, if you click on the predict button, you will just be given your output. So let's go back to your VS Code. Right, so you see I have given a submit button here, which has the value predict. Now let's go back to deploy.py. Once all your files are present in your folder, you can see I had trouble with saving my module earlier because my scikit-learn version was, I think, not updated. So I got it updated and then I had no issues. So now if you go to your deploy.py, open your terminal. I'm opening a new terminal here. Now what I'm doing is I'll be calling my local server python deploy, because my file name is deploy, deploy.py. Right, so when I'm running this, it is supposed to create a local server for me. Right, so if you see, just ignore this warning. It's just it just says that this is not a production deployment, right? And we won't need it for that. Now you can see our local server is running on 127.0.0.1 on the port 5000. So I'll just follow this link. Right, if you follow the link, you will have it opened in 5000 port, and you can see, right, you can see it is open now on the local server. So you can see our index is loaded here, sepal length, sepal width. So if I give some inputs, let's say I'm giving 2 as sepal length, 4 as sepal width, let's say 3 as petal length and 2 as petal width, and if we click on predict, right, it reloads, and then you can see it is giving us the class Virginica. Right, so basically we have our Flask web app running on a local server using VS Code and the Flask code. Now you can just click Ctrl C to stop this process, so your local server will be closed. Right, so our local server is now closed, but like whenever you want, you can just use python-deploy.py to run your local server, and it will be hosted locally. But we don't want it, because we are basically loading it locally on the 5000 port. We want it publicly shown so that we actually have some use case of the module. We could publicly launch a site with a better index, of course, and then people could use, give out values and classify which kind of species they are looking for. So let's go ahead and do that. I hope the Flask web app part is clear so far. Now we will go ahead and deploy this Flask web app to render, which will publicly host it for us. Alright, now let's jump into a bit of a fun part. So I'm back to my VS Code setup, and so now we have our file saved locally on a single repo, and now we need to deploy this on render, right? So in order to do that, we'll first have to transfer this repo on a GitHub profile. So before we push this code to GitHub, we'll need a new file, which you can see right here. It's a requirements.txt. So just go ahead on your locally saved repo and create a new text file called requirements.txt, or you can do it here from the VS Code as well. Just go and add a file. So you'll be adding a requirements.txt, and for these things, right, to add the libraries, I'll show you a command. So open your terminal and just type pip freeze. So what pip freeze will do is that it will tell you all the versions and the libraries you have used. So why we are doing this is when we are uploading our requirements.txt file on the GitHub, and when we'll be connecting our GitHub repo to render. So the render will understand what kind of libraries it has to install in order to run our Flask app on the render platform. So it's quite a critical step. Just create a requirement file and hit pip freeze. So pip freeze will basically show you all the libraries and the version. In order to transfer these libraries to your requirements, just type in pip freeze, just give a space and an angular bracket and type in your file names. So in our case, requirements, right? Yeah, just make sure your spelling is correct. requirement, right? So you will have to enter your file name, and then once you hit enter, all your libraries will be saved. And then once you have saved it here, make sure you push it to your GitHub repo. So just click on the version control, and since I have already committed everything, I don't have that option, but you will have a publish option here, so you can just connect your GitHub account to your VS Code, and then you will have an option to publish it there. So in my case, if I want to show you, here's my repository. It's named demo, which is the same name for my local repo, and here you can see all the files: checkpoints, template, which has my index file, my database, the actual notebook, then our deploy file, then we have our requirements.txt file here, and our saved models, right? So this will help us to further deploy it on render. Now if you are done with creating the requirements file, and then you have pushed your code to your GitHub, you can just simply open render. It's a fairly simple process. You can just click on, like, you will need to sign in first, and then you will have access to your dashboard. Once you're in your dashboard, you can just hit on new and click on web services. Here you can see your GitHub is linked. If it's not linked, you can just go ahead and link it. You will have an option somewhere here, and you can see all my repositories are already displayed here, and this is my demo repo. So I can just hit on connect, and it will ask me to give a name. I can just give any name. For example, iris deployment is what I have already created. Your region can be default. Your branch, in my case, I have two branches, main and master, and master is my default branch. But in your case, I suppose main would be your default branch, so there would be main written here. Root directory can be kept blank because we don't have a root directory. Runtime is Python. We are using Python 3. Your build command, right? So we just use a requirement.txt file, so this will be pre-written for you. And Gunicon app :app. So basically Gunicon is what will support our code to basically run globally, like run without a local app. So here app is your file name. In our case, we have file name as deploy, so we'll have to change that. We'll keep it deploy : app. App is our instance basically. Then we just have to select our instance type. So for now we are just going with free, that offers us 512 MB of RAM and 1 CPU, and just hit on create web service. I have already created a web service here, so I won't be doing that. I'll just go back from here, right? So you see I already have something called as demo, and I also have this thing. One sec. Yeah, so I have the demo file here, which has a failed build. I'll just go ahead and deploy the latest commit. Once I hit on the latest commit, because I was changing my requirements file, so right now it's deploying it again. Just make sure you give it enough time so it downloads everything, right? So it's downloading all the libraries right now. You will see, you can already see the link has been created over here. This is what will direct you to your web app. So you can see uploading build. right? So it's right. So it says build is successful and build upload in 9 seconds. It's deploying right now. So you can just hit your link and you will be redirected. So this is basically where your site will be hosted. Now if you look at my code, it's starting the service, so it will take some time. And if you see, when it's starting the service, it's using Gunicon. Now in some cases you might have an error here that that the render could not found Gunicon. In that case, just go back to your VS Code terminal and just hit pip install Gunicon. That way you will have Gunicon installed, and then it will help you to deploy it further. Right now I have an error saying that the D type I am using is incompatible. That's because I have used some other kind of library to save my model, and it's currently incompatible with render. So that's why you see my site is stuck on loading. So I'll just have some changes in my main notebook code, and I'll just get back. Right, so it has failed. You can see the deployment has failed because the D type wasn't compatible. Alright, so let me just fix this and get back. So alright everybody, I brainstormed on the issue and finally came up with a solution. So last time what happened was our build was successful on render, however our deployment was unsuccessful. So the reason was, last time I used a different library to store our saved model. That's why you will see in the previous clip that my saved model has a .sav extension. However, when I was using it on render, I was trying to unpickle it or use it via pickle, and since it was not saved by pickle library, it gave us an issue that the architecture wasn't compatible with render. So now, finally I have saved, I've used the proper library and resaved my model. And so you will see my git repo is now updated. You will see now the saved model has a different name. It is saved_model1.pkl. So right now my model is saved properly and it is now compatible on render. So apart from that, you will see some extra files. For example, you will see static, the new folder, and you will see proc file. So don't worry about that. I'll later explain in the video why they are added. So right now I'll show you the successful deployment of our web app. So right now, give me 1 second. I'll go to render. Right, so I'm back on render. You can see my terminal here. Unlike previously where we just had our build successful, you can see our build is successful right now. And also if you go down on the logs, you will also see after our successful build, you will see here your service is live. So basically our deployment has now also been successful. Apart from our build, you will see a live icon right here, August 1, 2023 at 1:27 p.m. we got our service live. And here if you click on the link now on the render, you will be redirected to our web app. Alright, so you can see our web app is now successfully deployed. Here you can enter your values and then you can hit on submit and get your results. So right now you will obviously notice that our index has been completely changed from the last index we had. It is now developed, so that's why we had those extra static files in our git repo. So now that the deployment is successful, I'll walk you again through what the changes were. So basically you have to resave your model. I just resaved it with a .pkl extension now with the proper library. And so earlier we used Gunicon to run it on render. We don't really need that. It makes the process a little hectic. So I'll just suggest you go to settings. And previously, so basically the earlier name I gave in the previous clip was demo. Right now I changed it to my own name. The region is same, other things are exactly the same. Your repo is same, branch is master, and the changes you have to make, even the requirements build command is same. The only change you have to make is the start command. So we used Gunicon deploy.py earlier. Now I just hit on edit and I have just edited it to python deploy.py. This is the exact same start command we used in our VS Code to deploy the app, the Flask app. So we are using the same command here on render as well. So that basically just makes the process a little simpler. So that is done, and you can see our web app is now hosted. Now coming to the index, so the previous index we had, so I have the copy right here in my demo extras. So this was the previous index file we were using, which was your sepal length, sepal width, all those entries, and then a small predict button, which is quite boring when you're hosting it. So then just to beautify the index, I am right now using a different index with some styling and stuff. So this is our new index file. You just need to the updated code will be there in my git repo. You just need to copy paste that code and you will have this, your sepal length in centimeters, and I have added this extra option where you can just, instead of typing, you can just hit on these arrows and you will have your values, and there's just some image. And so for example, now I'm just putting in some values. I'm just using 1 2 3 4, and when you hit on submit, it will give you your species detected iris virginica, and you will have the image displayed as well. So for that, if you see, my git repo had new files, right? So basically, when you have your index file inside your templates folder. Along with that, you have to just create a new folder named static. In that, make another subfolder called image. In that, I just have these 3 images saved, which are basically the output images when the species is detected. These are the image outputs you get. And then we have a style file. The code will also be provided in my repository, so you can just create a new folder named static, and that's where you can store your styles and your images. So upon deployment, instead of that basic index, you will have this better one, and you can see the prediction is going perfect. Yeah, and that's all. So again, on render, you can just copy paste your URL from here. In my case, since I changed the name from demo to Yash, it is now yash-yz82.onrender.com. So yeah, you can copy paste this and then access it from anywhere. That was our successful deployment of the Flask app on render, and basically a use case of our ML project and our saved model. So thank you so much for sticking around for so long, and hope you have successfully deployed your model as well. If you have any queries, any problems regarding the same, then you can just comment it down or write it to us on our emails, and then we'll surely get back to you. Thank you.